What's up, my chem friends? Last time I saw you, we were talking about what is a mole and then how can you express a weight of a mole. So let me give you an example, and it's kind of an example that I've been kicking around, and that has to do with a dozen of eggs. If I told you to go to the store and get a dozen eggs, you came back with 12 eggs, I would be very excited because a dozen is the same as 12. But I mean a dozen chicken's eggs, right? And maybe you go to the store and you buy a dozen robin's eggs. If you've ever seen a robin's egg, they're about that big. They're very, very small. A dozen robin's eggs is not enough to do my baking because they're so small. And that's where molar mass comes in. So maybe instead of saying go get, a dozen eggs, I'll say go get 50 grams of eggs, because then it doesn't really matter what species of eggs you get because I'll have the right amount to cook with. Likewise, in chemistry, we need to mass out our reactants and our products. We just use a scale to figure out, well, how much do we need to make our product? And so it's important that we can figure out how much 1 mole weighs in grams. So if I'm starting with 50 grams of copper, well, how much copper is that really in terms of individual atoms? And that's where molar mass came in. So when we were talking about molar mass, I needed you to understand how much weight a mole has. And that is simply because if we wanted to do a reaction, which we typically would be doing if we were in person, all of us, I would have you literally measure out in grams how much of a reactant you would need. And then you would figure out how much of the product you got by looking at it in grams. And then we could, what was that? That was my email. We could then figure out if our reaction was good or not by figuring out the masses of the reactants and products and then just comparing it to how many moles. And we'll do that in 4.4 when we get to stoichiometry. So what was a mole ratio? Well, a mole ratio let us compare reactants and products. If you start with 2 pieces of bread, you'll get 1 sandwich, and that comes from the coefficients. Now, since we can't track individual atoms, we'll track moles. A mole is just like a dozen. So if you start with 2 pieces of bread, you'll get 1 sandwich. If you start with 2 hydrogen atoms, you'll get 1 water. Looking at the coefficients from the balanced chemical equation, we should be able to figure out reactants and products. And then we can take it one further by massing those things. So what we're going to talk about today is molar mass, but really how we're going to use molar mass as a conversion factor. Before we get anywhere, I just want to remind you that a mole is simply a counting unit, and it's a way of expressing a certain number of atoms. So if you had a mole of beach balls and a mole of bouncy balls, you would have the same number of individual things. But a mole of beach balls, they're much bigger. They take up much more space. You could have a mole of paper clips and a mole of gold bars. You'd have the same number of things, but the gold bars will have much more mass, and that's called molar mass. So being able to calculate it, talk about the units, and then use it as an equivalency statement, this is really what we're going to do today. So the mass, again, of 1 mole is just called the molar mass. And we found last time that the molar mass of H2O is 18.02. That's because we have 2 hydrogens and 1 oxygen. Every hydrogen has a mass of 2, every oxygen has a mass of 16, and we can look that up on the periodic table, add them together. We'll get 18 grams is equal to 1 mole. So 1 mole, if you had 602 sextillion atoms of hydrogen of water, that would weigh 18 grams. But this right here is an equivalency statement. They're equal to each other, so we can write 2 conversion factors out of this. I believe I'm highlighting it to point to the fact that it is an equivalency statement that we can write conversion factors from. And one of those conversion factors would say 18 grams of water is in 1 mole of water. What's the other equivalency statement that we could write? We could flip it upside down and say 1 mole of water is equal to 18 grams of water. Because remember, 1 mole is equal to 18 grams. We know that 1 mole is equal to 18 grams. So this is just like writing 18 over 18. 18 over 18, that cancels. This is just a really fancy way of writing 1 because they're equal to each other. And equivalency statements allow us to convert our units. So make sure you have the 2 equivalency statements written down in your guided notes. Because we're going to do a practice problem. And that practice problem says, how many grams is 12.5 moles of water? So we're using those same dimensional analysis charts that we were using earlier in this unit the same dimensional analysis charts that we were using earlier in the year, where we'd put the given in the top left and then the equivalency statement in the right. So in this problem, what is the given? 12.5 moles. So I'm going to stick that where given was. And you should also stick it down right underneath this over to the left. There's a yellow box for you to fill in. That's 12.5 moles. Now we need to use the equivalency statements that has the right units. Well, we're converting from moles. That's our given. We're converting from moles. So I need moles in the bottom. What am I trying to convert to? I'm trying to convert to grams. So I can just plug in my units of grams and moles. I need to know the equivalency statement between mass and moles for water. But luckily, we just wrote down those equivalency statements. It was the molar mass. And the molar mass of water is 18 grams. 18 grams of water is in 1 mole of water, or we could write it this way. 1 mole of water is 18 grams of water. So which one of these equivalency statements do we want to use? Well, we want to use the one that has grams in the top and moles in the bottom. Which equivalency statement has grams in the top and moles in the bottom? This one does. So I'm just going to plug in this equivalency statement, just 18 grams over 1 mole right there. So again, I matched the units. I want to convert 2 grams. I'm converting from moles. So I plugged in my equivalency statement. This is equal to each other. This is called the molar mass here. And so what does this exactly mean? That vertical bar means multiply. So you do 12.5 times 18.02 divided by 1. And I already did this for you. You get 225.25 grams. Why grams? Because the moles cancel out. You have moles in the top and moles in the bottom. So what I'm trying to tell you is that if you need to do a reaction, and in that reaction you need a certain number of water molecules. You need 12.5 moles, which is a ridiculous number of water atoms. But I mean, you drink hundreds of moles of water every single day. So you need 12.5 moles. And we need to know how much water to measure out. Well, every mole of water weighs 18 grams. And so in total, you need to start your reaction with 225 grams. This is a short screencast because I'm hoping that you're building these skills one on top of each other. In the worksheet that follows this today, you'll convert from moles to grams, from grams to moles. And how are you going to do that? Well, you need to find the molar mass first, and then write the equivalency statement second, and then figure out which equivalency statement to use third. Now, grams isn't always going to be in the top. Grams is in the top in this case because I'm asking you to convert 2 grams. If I wanted you to convert 2 moles, then you would have moles in the top and grams in the bottom. So give this a try. We'll go over it next time I see you in the afternoon. And remember, it's a Google form, so submit it until you feel comfortable on it. If you need more practice, let me know. I'm happy to point you in the direction of some YouTube videos or whatever resources I can give to you. Thank you for watching. I'll see you next time.